Hello, I am Satyabrata Maiti. I am pursuing my PhD from Science of Nuclear Physics in Computational Chemistry. Today I will discuss about equivalent weight, why it is important to know equivalent weight, and then I will discuss what is the relation between equivalent weight, valency, and atomic weight and atomic weight. Let's start from the definition of equivalent weight. Usually, we uh, define equivalent weight by E. Okay, so what is the definition? Definition is the equivalent weight of an element is the mass that combines with or displaces 1.008 gram of hydrogen or 8 gram of oxygen or 35.5 gram of chlorine. So now, uh, what is the relation between equivalent weight, atomic weight, and valency? Let's say equivalent weight of an element. Here, the notation of the symbol of element, say M, is E, valency V, and atomic weight is A. As the valency of the element M is V, so obviously it V number of hydrogen will can combine with uh, M. Then the formula of the compound will be MHV. This is the formula of the compound when M combines with hydrogen. So if the formula of the compound is MHV, then it is clear that V into 1.008 parts of hydrogen combines with A parts of uh, element, and 1 parts of hydrogen combines with A by V into 1.008 parts of the element. So now, by definition, what is the definition of equivalent weight? The definition of equivalent weight in terms of hydrogen scale, it is the mass of the element which can combine or displace 1.008 parts of hydrogen. So now, 1.008 parts of hydrogen combines with A by V into 1.008 into 1.008. It's just a simple unitary method. Now 1.008 and 1.008 cancel out, so it becomes A by V parts of element. As 1.008 parts of hydrogen combines with A parts of element M. It's better to write element M. Uh, in that case, I can say that this A by V is the equivalent weight of M. Clear? So now you can write the our new equation, that is E equal to A by V. From this equation we can say that equivalent weight of any element can't be greater than its atomic weight, as equivalent weight is the atomic weight divided by its valency. Clear? Another important thing which I can draw from above equation is that equivalent weight can't be zero. Clear? Now I will discuss that why it is important to study equivalent weight. Okay. For this, now we'll discuss for the importance of equivalent weight in chemical reaction. Just chemist starts a reaction by taking reactants in some specific mass ratio. Uh, for this, consider the example of formation of water, that is 2H2 plus O2 2H2. So 2 moles of hydrogen reacts with 1 moles of oxygen to give 2 moles of water. So 2 moles of hydrogen means 4 gram, 1 mole of oxygen means 36 gram, and 2 moles of water means 36 gram. So here it is evident that hydrogen, oxygen and water maintains a specific ratio, which is H2 O2 is to H2 4 is to 30, it is 32, 32 is to 36, it is 1 is to 8 is to 9. So we have to take hydrogen and oxygen in a proportion of 1 is to 8 mass proportion. But to obtain this, reaction must be balanced before starting this calculation, this simple chemical arithmetic. But we can get the same data, same information from chemical equivalent, from equivalent weight. How we'll get the same information, same mass proportion using equivalent weight? Now consider the equivalent weight of hydrogen. What is the equivalent weight of hydrogen? We know equivalent weight of any element is E equal to A by V. What is the atomic weight of hydrogen? 1, and valency is 1. So equivalent weight of hydrogen is 1. And equivalent weight of oxygen, what is the atomic weight of oxygen? 16. So A by V, and the valency is 2. So it becomes 16 by 2 equal to 8. And what is the equivalent weight of H2? Here we are not able to calculate the equivalent weight of water just by E equal to A by V. Rather, we can calculate the equivalent weight of water by some addition rule. Just we have to add the equivalent weight of hydrogen, which is 1, plus equivalent weight of oxygen, that is 8. As equivalent weight in a compound follows the addition rule, so it becomes 9. So equivalent weight of water is 9. Just now, just see, so mass proportion obtained from equivalent weight is H2 is to O2 is to H2 equal to 1 is to 8 is to 9. We get the same mass proportion from equivalent weight, but here we don't need balanced chemical reaction, and that is the beauty of equivalent concept of equivalent weight. So equivalent weight is independent of balanced chemical reaction. Whereas mole concept is dependent on balanced chemical reaction, and that is why equivalent weight is preferred over mole concept while starting a reaction, because it will be very laborious to balance a complicated chemical reaction. Okay, so in next class we'll study how to calculate equivalent weight of acid, base, some salt, oxidizing reagent, oxidizing and reducing reagent in redox reaction. So today I'll stop here. I stop here. Thank you.